Hi everyone. Okay, today we have to see something important. Uh, that is, how is a complex number expressed as an exponential form? Sorry. Any complex number x plus yi with its moduli r can be expressed as r times e to the power of I theta, where theta is the argument of that complex number. So this is based on the Tylor series. Tylor series basically says that f of x is equal to the summation of x minus a the power of n f n's derivative of n I mean f at a over n factorial n is any number starting from 0 up to infinity. So this is the same as f of x is equal to x minus a the power of 0 times f at a. We haven't derived f, you can see that, over 0 factorial plus x minus a the whole 1 the power of 1 times the first derivative of f at a over 1 factorial plus x minus a square the second derivative of f at a over 2 factorial, and it continues like this. So we have to see some example now. Example, f of x is equal to ln x. You know, x must be definitely greater than 0. Uh, Now, our choice is a is equal to 1, not x, a is equal to 1. So ln x can be expressed as x the power of x minus 1 the power of n ln n's derivative at 1 over n factorial. Ln x is equals to x minus 1 the whole 0 times ln the original function at 1 over 0 factorial plus x minus 1 the whole 1 the first derivative of ln, that is 1 over x, but x is substituted with 1 plus x minus 1 the whole square the second derivative of ln, that is minus 1 over x square, and we substitute in place of x is equals to 1, so it continues up to n. That means ln x can be simplified as 1 plus x minus 1 plus minus x minus 1 square over 2 factorial plus 2 times x minus 1 cubed over 2 factorial blah blah blah. So ln x is like this. So based on this, sorry, the Tylor series for e to the power of x e to the power of x can be written in the same way. The first derivative, the original function is e to the power of x, so we choose a is equal to 0. It is a critical number. What makes e to the power of 0 simple? E to the power of 0 is equal to 1, so there is no better number than 0. So e to the power of 0 x minus 0 the whole 0 at the power of 0 over 0 factorial plus e to the power of 0 x minus 0 the whole 1 over 1 factorial plus e to the power of 0 x minus 0 the whole square over 2 factorial plus blah blah blah. Because here we are e to the power of the we are continuously saying e to the power of 0 because the derivative of e to the power of 0 e to the power of x is e to the power of x, and we have substituted a in place of 0 in place of a, so it is e to the power of 0 always. So e to the power of x can be expressed as 1 plus x plus x squared over 2 factorial plus x cubed over 3 factorial blah 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 blah. So the same is true for sin x. Choose a is equal to 0. The uh, the original function sin at 0 minus x minus 0 is whole 0 over 0 factorial plus cos, the cos is the first derivative of sin, so cos 0 times x minus 0 is whole 1 over 1 factorial plus the second derivative of sine is equal to minus sine, so substitute 0 times x minus 0 whole square over 2 factorial blah blah blah. So sine x is equal to x minus x cubed over 3 factorial plus x to the power 5 over 5 factorial plus a minus x to the power 7 over 7 factorial. It continues like this. For cos, choose a is equal to 0. Cos x is equal to cos original function at 0 times x minus 0 is equal 0 the power of 0 over 0 factorial plus the first derivative of cos is minus sine, so substitute 0 in place of x minus 0 the whole 1 over 1 factorial. It continues like this, and cos x comes 1 minus x squared over 2 factorial plus x to the power of 4 over 4 factorial minus x to the power of 6 over 6 factorial, and it continues like this. The very fundamental formula is this Tylor series. We are done all the three based on this. So what? Uh, uh, for if we substitute ix in place of x here, in place of x, let's substitute ix. It works for any variable. So ix may be y. So now in the same way we choose a is equal to 0, so we will get, just substituting ix in place of x, we have got this general formula. But now ix is equal to ix, substitute ix in place of x, so you will get this formula. Definitely it is true. So it can be simplified like this, and substitute those terms without I in one place and with I in the other place. So I've done like this, and you can see that this the first trace is equivalent to cos x, and the second one is equivalent to sin x but multiplied by I. So we have got cos x plus I sin x, and this is the as you see, cos x plus I sin x is a plus bi. If a is equal to cos x and b is equal to sin x, it is a complex number. So a is equal to cos x, b is equal to sin x, it is a complex number, a plus bi. If I is the power of x is multiplied by 1, and 1 times e to the power of I is equal to 1 times cos x plus I sin x, and if it is multiplied by r, we'll get r into cos x plus I sin x. So, and you know that r cos x plus I sin x is the formula for a plus bix bi with modulus of r and its argument x. So this is based on this concept. This is driving based on this concept. Thank you very much.